Okay. Okay. Shh. We have a question before we start on the mole. Yes. 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 So the question was, when you're doing conversion factor with moles, do you need to write, like, let's say we had 6.02 times 10 to the 23 CO2s. That would be per 1 mole of CO2. Okay? Yes, you have to show this here. And we don't, and it is important that the order you write it in, okay? We never say CO2 moles. We always say moles of CO2. Just like you would never say, I want a donuts dozen, right? Would you ever say a donuts dozen? No, you would say I would like a dozen donuts. I would like a mole of CO2. Okay, so the CO2 comes after the mole. Okay, so that would be the molecules per mole. That is a good question. Did anyone have any questions for the test? I never did get to that. I lost it. You lost your question? Okay. Alrighty. Mole conversion factors. What is one conversion factor that we know about the mole? Hi. Sure. We don't know any?
6.02 times 23 times 10 to the 23. It's 1 mole atom.
6.02 times 10 to the 23 particles equals 1 mole of particles. Okay, that is worth knowing because you are expected to memorize it. Okay, there will be several conversion factors in this unit that you are expected to memorize, and that is one of them. So particles could be atoms, and then it would be per mole of atoms. It could be molecules per mole of molecules. It could be 6.02 times 10 to the 23 ions per mole of ions. I'm not going to write out 6.02 times 10 to the 23 4 times because that's exhausting. But it doesn't matter what particle you use as long as it is consistent from side to side. You cannot have 6.02 times 10 to the 23 atoms and convert it into a mole of molecules. It doesn't work like that. Does that make sense? It would be like if I said, I have a dozen bicycles. Does a dozen bicycles equal 12 wheels? No. Okay, so a dozen bicycles equals 12 bicycles. You would then have to do a second conversion to get to wheels. We learned a second conversion factor. Okay, you don't have to write out all of these. You just need to know this one, right? Those other ones are just examples. We learned another one in class last day. What was that other one that we learned? Atoms and molecules. We learned the particle ratio. Yeah? And the particle ratio is not as nice to write down because it isn't the same every time. Okay, a particle ratio would be where if we had, let's say C12, H22, O11, we would say we have 12 carbon atoms per 1 C12H22O11 molecule. Yes? And the only way to do this, the only way to find the particle ratio is to use the formula and count. Does that ring bells? Remember doing that last week? Okay, cool. So let us carry on with a little bit of that. Back in, let's see, where are we at here? That's the one. So we want to be on page 16. Last day we were converting atoms and molecules because we were doing covalent compounds. Today, we're working with ionic compounds. Did I say page 14? 16? Thank you. So if you remember, a formula unit is like a molecule, but it's for an ionic compound. So if we took our ionic crystal lattice and we took a single unit of that ionic crystal lattice, that is called a formula unit. And if you want to abbreviate it, you can abbreviate it like that. I won't say it because it's a little rude, but that's what can we do? That's how it abbreviates, okay? It's either that or write it out every time. So it's like a molecule, but it's for an ionic compound. They're not molecules because molecules are only bonded by covalent bonds, and molecules have a set composition. Molecules are only ever what it says in the formula. Water is H2O, it's never H4O2. It's never bigger than H2O, it's just H2O. Whereas sodium chloride, you could have Na 1,000,000, Cl 1,000,000. You could have Na9, Cl9. You could have what, as long as the ratio is 1:1, it can be different. But molecules only ever have a very fixed number. Okay, ionic compounds have a fixed ratio. Molecules have a fixed number. So that's why we call them formula units rather than molecules. Remember, ionic compounds don't exist as molecules. They go on and on indefinitely in a 3D ionic crystal lattice. So a molecule has a fixed number of atoms, whereas a formula has a fixed ratio. Now, if we have calcium phosphate, if you recall from our writing formulas unit, we have a 2+ charge and a 3- charge. And so we need to have 3 of these and we need to have 2 of those. And so our formula unit is Ca3PO4 2. So far, so good? And if you want to know what that looks like, it means that you have 3 calciums, calcium, 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 for every 2 PO4s. All right, that's what a formula unit of calcium phosphate looks like. And now we're going to go through some questions. How many calcium ions are there in 1 formula unit of calcium phosphate?
3.
3. Many of you on your report card comment will have a comment that says, what is it? Because we're supposed to give you something you can do better. And for, if you're getting like 94% or above, it's really hard to do better. You know what I mean? Like you've made silly mistakes or whatever. But my one comment that I put in is you could participate more. Join in class discussions, even if it's just like one thing. And you don't need to worry about that because you do that all the time anyway. But I know a lot of you out there know things. So join in. Join in, have a conversation with me, okay? How many calcium ions are in a formula unit? 3. So let's write this as a conversion factor. We have 3 Ca for every 1 Ca3 PO4 2. And now I would like you to critique. I would like you to critique my conversion factor. I am missing something. Have a little chat with your partner, see if you can figure it out. What am I missing? What did I hear? Charge. Yeah, okay. We need to have Ca2+. Now, I feel like it is optional for you to write Ca2+ ions for every Ca3PO4 formula unit, okay? I'm going to say that those things are optional, okay? Yeah. So up to you whether you use that or whether you just stick with the actual particles. Yeah? So there's really not much to it. If you can write the correct formula, you can find the particle ratio. Remember, this is the particle ratio. What do? You write the formula and you count. So now let's use our formula ratio. And if we have 16 formula units of Ca3PO4, how many Ca2+ ions do we have? Well, we want to find the number of Ca2+ ions, and we are starting with 16 Ca3PO4 2, and you can write formula units. Okay? Well, yeah, I know, but we need to show our work. Yes. Well, it's not always going to be this easy, okay? Like we're starting with the very easiest, which is the way to go about it, but it makes people think they can do it in their head too. So it's like, no, because later it won't be so nice. All right, so we have those many formula units. What do we need on the bottom to cancel? Ca3, PO4, 2. And on the top, what do we need? 3 Ca2+. And you can write ion, but honestly, because it's got a 2+, you are telling me it's an ion by having that charge on it, yes? So whether you say ion or not is up to you. Formula units, okay? And then we do our math there, and we get, you're absolutely correct, 48 Ca2+. And when you're writing the answer, you should write Ca2+ ions because it asks how many calcium ions, and so you should just do that. There we go. How many phosphate ions are in one formula unit? You go to your formula and you literally say, How many phosphates? Look at the formula. There are 2 phosphates. Yes.
We ever be asked to like individually, like if I were to, so in this question, if the question were to ask me how many oxygens are in this?
Yes, we could do that also. Okay, so yeah, we could ask for phosphate ions, we could ask for oxygen atoms, we could ask for, yeah, okay? So we could break that down, that formula down in any way we want to, okay? How do you like my answer there? There's no charge, okay? 3 minus. Anytime you write an ion, it must have a charge. Otherwise, it is a completely different chemical species. It would have totally different properties, okay? And writing that as a conversion factor, 2 PO4 3 minus. And I have not done a good job of writing my O. I want you to make sure that your O's, capital O's, look like capital O's. 3 minus. Don't write polonium, PO. Okay? I'll get the idea. I mean, if you do this, that's okay. No big deal. But no little tiny O's, because that's polonium. Okay? Polonium is an element.
Oh, yeah.
Yeah. All right, for every 1 Ca3, PO4, 2. If you have 18 phosphate ions, how many formula units of Ca3PO4 can you make? So we are saying, how many calcium phosphates can I make? And I'm starting with 18 PO4, 3 minuses. What do I have to put on the bottom? Yeah, I have to put my PO4 3 minus on the bottom, and I need to put my Ca3 PO4 2 on the top. Now, by the way, if you on your Unit 2 test did not do so hot on unit conversions, this would be your time to really pay attention so that you learn it this time through, okay? So we have 1 of those and 2 of those. That's going to give us 9 Ca3 PO4 2. And you'll notice this time I did not write formula units or ions because I got a little lazy, and that's okay. All right. But in my answer, I should write formula units. What is the conversion factor between calcium ions and phosphate ions? Yeah. All you got to do is, once again, you're going to look and you're going to say, I look at my formula, I have 3 calcium, 3 Ca2 plus. How many phosphate do I have? 2. So we have 2 PO4, 3 minus. How many phosphate ions would it take to completely react with 6 calciums? Do you guys want to try that one on your own? And just remember, you can take any conversion factor and turn it upside down. When I originally wrote the conversion factor between calcium and phosphate, I had 3 calcium on the top, 2 phosphate on the bottom. But when I used it down here, I put the 2 phosphate on the top and the 3 calcium on the bottom. Is good? Okay. You can also convert between formula units and atoms. Oh, here you go. This is exactly what we were talking about earlier. Let us see, can we write a conversion factor between calcium phosphate and atoms of O? 1 calcium phosphate How many atoms of O is that? Tell your partner. Whoops. We have the 4 inside the brackets. We have the 2 outside the brackets. So that gives us a total of 8 O atoms. Okay. Now, I know I said you can sort of like leave off the ions and stuff, but if you don't write atoms beside O, it just looks weird. Do you know what I mean? If you just write 8O, it looks like you're trying to write 80. It becomes unclear. Okay, so just think about what you're writing. Have you made it clear enough? Okay. Atoms of P, if we have 1 calcium phosphate. How many P's do we have? 2, because that 2 applies to that P, so that's 2 P atoms. Formula units of calcium phosphate and total atoms. 1Ca3, PO4, 2. Tell your partner how many total atoms there are in that formula unit.
Oh, yeah.
So we have 3 calcium, we have 2 phosphorus, and we have 8 oxygen. So that gives us a grand total of 13. And those are just generic atoms. So we don't need to put anything in front of the atoms. Do you guys want to try the next few questions on your own? Okay.
You should have gone. Yeah, I also heard that. So we need like.
Okay, that's all right, We got this, okay? What's your favorite one? Fine. Sorry, yes. Okay. And so there's one. Are you members tomorrow? Yeah. 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 Yes. Yes. Exactly. Yes, because well, because you go to muddle and love, not metal, that's ironic, because you need to say it's not. You need to show the formation, you need to show the electrons moving. That's the end product. That's not what you need to show. Exactly. You would show so that I should never mind. Okay. Yeah. That's for that. I can't believe that. I would volunteer and then. Okay. Yes, help yourself. Yeah. Knowledge is I could also say, but yes. A lot of people are say like. Yeah. Okay, how are we doing? Those look so good. Yes, very nice. And then you would just need to make sure you got your units there and your units there. They're just, yeah. Okay. So, yes, I want to. Yes. Okay. Oh, yeah. Okay, so you are not starting with p atoms, you are starting with formula. Okay, that's your initial point. So you're gonna write instead of p atoms. Right. You're gonna write 128 C. Just write it out. Okay, you see it, right? Yeah. I'll spot it, but they apply longer because it's a long formula. Yeah.
I'm broke now. I don't have orchids and license. I'm not. Generally, it's enough, but like, if you get sold into the
Yeah.
Okay, 70, you know, like, oh, 4 is a lot, and you got like 72.
Yeah.
Like, sorry, you're flexing, like, stop flexing on us 4. It's like, I feel like a peasant, though, in like the middle English. I don't think that. Single mother of 3. This is ridiculous. 72 I feel like that's I feel like I'm providing for like one family. Like, I try to like minimize it one day, and I one time I accidentally left my cellular. I turn my cellular data off whenever I'm using Wi-Fi, but it's being used on the background. One time I accidentally left it on when I was doing just and I almost cried afterwards because I was so afraid of using all my data. How did it feel to be are you a girl? What was the point of having a problem then? They're supposed to so you have to call you. I had to go with that.
Yeah. Tell you no.
As a natural relationship, my role. I'm not gorilla, you can track.
Yes. 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 You're okay? You're just like, yeah. Yes. Okay, who have I not seen yet? I was gonna Oh.
What, you were programming to hear the oh,
I got talents. I got my feel good. Okay. So, where did we get to? Brennan, I'll put that up in a minute, okay? Or was it Dylan? One of you. It was you. Okay, I knew it was one of you back there. Okay. There we go. Nope, that one. Okay, so it was crappy, but it got all my local presents, so it was actually really fun. Okay, so you need to either figure out how to put this in scientific notation, which will depend on your calculator, or you can go, I'm just going to multiply by 1,000 to get myself some more digits. And then you're like, oh, maybe I get 3 more digits, and then you just have to remember that you multiplied by 1,000 when you're counting your scientific notation. Okay, but I would say it's probably worth it to figure out. Let's just check this one. No, let's try one. No. Okay, never mind. Side fix 9. Yeah, that was your 9 digits. And then shift mode. You're going to take it to fix, which or normal. Okay, so that would be 9 digits fixed decimal, and then normal will give you a floating decimal, and then it will change the scientific notation when necessary. Usually, that's okay, friends. Sorry for the delay. Why my pen not work? That make me not happy. Okay. Okay, so check your answers. You should always say, we are looking for our unknown is equal to our initial times the conversion factor. So our unknown is how many phosphorus atoms, how many oxygen atoms, how many total atoms. Okay? And then our initial quantity is whatever we're given. We're given 128 Ca3PO4. So we're going to put that here. 128 Ca3PO4 2. And then we're going to go to our next one and we're going to say, whoa, what happened here? That's no good. Sorry. Oh, I see. Why will you not behave? There we go. Okay. What's our initial quantity? 128 Ca3PO4. So let's do that again. 128 Ca3PO4 And what is our last one? Oh my gosh, it's 128 Ca3PO4 Then we need to multiply by the conversion factor. So you're going to draw a line, line, line. That is going to be your conversion factor. Okay? On the bottom, whatever you have on the top, whatever your initial is, you want to put that on the bottom. Whatever the initial is, you want to put it on the bottom. Whatever the initial is, you want to put it on the bottom. Not the number though, just the unit. So this is not 128 Ca3PO4s. This is just Ca3PO4 2, not 128 Ca3PO4 2. Okay, because we're not looking for the ratio of 128 Ca3PO4 2s to the calcium ions. I mean, you could do it, but it would be really awkward. And what are we trying to find? Whatever you're trying to find goes on the top. So in the first instance, we're looking for P atoms. In the second instance, we're looking for O atoms. And in the third instance, we're looking for just generic atoms. Oh, and these ones were Ca3, PO4, 2, Ca3, PO4, 2. And the number of P atoms, you go to your formula and you look and you say, how many? There are 2 PO4s, or sorry, 2 Ps. There are 2 times 4 is 8 Os. And then we calculated earlier that there were a total of 13 atoms in that thing. So these are all 1, 1, 1. Is good? Okay. And then I guess we could do our last one as well. How many Ca3PO4 how many Ca3PO4 can we make from, what is our initial quantity in this case? 128 O atoms. Now remember, we're going to take just the unit, not the number, just the unit, and put it on the bottom of our conversion factor. O atoms. And we're going to take what we want to find, which is Ca3PO4, and we're going to put it on the top. Ca3PO4 2. And you'll notice I left space at the beginning so I can put in some numbers. Yeah? How many O atoms? There were 8 O atoms in every one of those. So when you're converting between particles, your numbers should be small. Usually. Yeah, it's going to be like a 1 to 8 or a 1 to 13 or a 13 to 2 or something like that. They'll be small numbers because you're counting using the formula. Okay? So, what I'm going to have you do for homework is actually not for homework because you've got a test tomorrow. I'll let you study for your test. But right now, you are going to work on pages 18 and 19. And if you run out of that, 18 to 19, and if you run out of that, you can also do pages 9, 10, 11, 12. But don't worry about it if you don't get to it today. Okay, so get a start on that today. When you finish your test tomorrow, you will continue working on it. Okay, so you get a start on it today. You can continue working after your test tomorrow. Your test will not likely take you the whole block. Okay? Yes. Yeah.
Yeah, but this test will be.
This test is gonna be a full test.
Yeah.
Yeah. It'll be longer. Well, I mean, how long was the formula test? Not very. Okay. And this one's not very. Not very long.
It's maybe like 15 minutes, and I'm done with that.
Yeah. Yeah. And if you're a slower worker, if you don't know your stuff, you have to think about it more, maybe you double that, but you know, yeah. Half an hour-ish.
Oh, wait, I thought. I was probably in the lab.
Okay.
I can't join it. It's like-
Oh, okay. How many classes do you have? Yeah. Oh, and that reminds me to get the. It will not do this. Yeah, we already did a quiz on that other one, and I'm done with it. It's really,
Well, yeah.
Yes. You know what I'm gonna do? I'm gonna print it right now. You sharpen, I print. You sharpen, I'm gonna print something.
Yeah.
Yeah. I'll be right with you.
Uh,
Sorry. Okay.
coming out or?
No, it's all good. Don't worry. Okay. Who wants another copy of the practice quizzes? 1, 2, 3, 4, 5, all of you. Okay. I'll just make a lot of copies of it.